Okay, I've said this is a précis. There is, there will be an annotated session log comes this the end, with the various limitations and anomalies associated with with this. Okay, I'm using a model. What I'm proposing doesn't currently work in Dialog APL, and so right. Just here are some APL expressions. This is a vector. This is a character string. This is a nested vector, a list of strings, a mixed vector, and another. And I believe I might have to reduce my font size again in order to show you the next screen. Right. This shows the expressions I've just shown you. On the left, in the middle is the default display for those expressions, and on the right is the result of the display function on those results. The display function is quite explicit. We can easily see that this is what it says it is. That this is a nested vector, and that these, because of the plus sign below them, are mixed vectors. Equally, the expressions themselves, no difficulty in understanding what that is saying. The same with the nested vector. But in terms of the mixed arrays, they are obviously, we can actually see which is which of these characters and numbers, which we cannot see with the display version. Okay. So there's ambiguity in both the default and the display functions, and also in multi-dimensional arrays, if we use those. The display function is actually quite good in a lot of ways. I actually, about 25 years ago, wrote an editor using quad SM along with display to edit any damn thing, as long as it wasn't ambiguous. But expressions themselves are never ambiguous. They do have limitations. We can't denote a one-item vector in notation without a function call, nor can we denote multi-dimensional arrays without a function call. I'm differentiating here between notation and code. Notation is just the pure syntax without any functions running at all, which includes all of vector notation. Even in a simple example of a multi-dimensional array, we have to work harder to understand what we're looking at. The shape vector, the reshape, the data itself. We have to work out what we're going to get. Right, with vector notation, we don't even have to execute the expression to know exactly what we're going to get. So I won't bother. So how could we express multi-dimensions in notation? And why do we need to? Well, obviously what Morton was saying about scripts. If you code your system in a script, you cannot store an array. You have to create the thing at startup of your application, and perhaps keep it for the session duration. These would be things that you refer to over and over again, lists of the months of the year, for instance, error codes, these kind of things. They're difficult. They might be difficult to maintain, but so in any case, it's probably not the best thing to store them in workspaces or files. Just create them on the fly, but they need to be. It needs to be done somehow or another. Here's an array that always amazes me how Bjorn managed to maintain this thing as he was developing DRC. Very difficult to edit. He must have been indexing bits and pieces in and out of it and so on. So what's the alternative? How can we generate an array in code or in notation? Here's just a simple matrix. APL2 used to have a thing, or probably still does have a thing called quadcf. You gave it the name of an array or a function, and it returned an expression which would recreate that array. Now, it's not in Dyalog, which is why we've got the syntax error there. But creating an array, a vector, a string that would, an executable string that would recreate it, was what quadcf did. It's difficult to read. You don't know where the line ends are in this thing here, so not the best solution. Here's one that you've all done at various times. You create a function, you put the array itself inside the function, and you concatenate each row of it into an array, into a result variable, and return the array. So that works. Here's another way of doing it. Just as old, it's been going on for years. You put the array into a function, only instead of multiple assignments, we just comment the thing and we extract the data from the quadcr of the function itself. And that works as well. My first go at this was actually about 30 years ago, a thing called attached text. You told it what its caller's name was, because there was no such thing as quadsi then, and it extracted the contiguous comments from the bottom of its caller. Kai Jaeger has produced this documentation facility called ADOC, which equally pulls comments out of the scripts it's given along with markup and produces various document types. Brian has recently written a function called script follows, which again does the same thing. It pulls the contiguous following comments from its caller. And that's actually engendered forum discussion where lots of people saying how much they like it and how much it could be improved. So what all these show for me is the desirability of expressive code. If you want to create a 3-row matrix in code, you want to do it as 3 lines of code so you can see the 3 separate lines of the data. The implication is that we want a multi-line expression, and preferably without a function call because they just get in the way. Defins. This defin is just a one-liner, but it's got 2 diamonds in it. It's got 3 expressions inside. We've got an embedded defin with those, and that's in parentheses. And basically that's what it does. We can break this line with its diamonds into three separate lines, and it's still going to work. No trouble at all. But if we actually look at the function, syntax colouring has recognised that we've got broken, unbalanced parentheses here. So the reason it works is because the line ends are between the braces. Now what I want to do, in fact, oops, I know what I did there. Sorry, no. Insert. Right. What we could do, of course, with the same function is break it after the parenthesis before the brace, and it would, in fact, give us a syntax error. So we don't want to do that. But what we want to do is transfer this ability of APL to have line ends between parentheses, between brackets, and so on into ordinary code. And in this case, I'm using a bracket. And these brackets indicate that we've got a 3-line expression. And there's only one thing you could possibly do with that and say, well, it's obviously a matrix. So let the function return a matrix. It doesn't have to be brackets. In fact, it probably wouldn't be brackets because they're too mixed up with indexing, axis, and whatever else. It's been suggested that bracket be used for something else, which I probably won't mention because there probably won't be time. But there's all sorts of stuff in Unicode that could be used for a similar job. These are just showing bracketing pairs with line ends between them, all of which are, of course, syntax errors at the moment. I'm not keen on the diagraph. The bracket there is going to be very confusing if you've got a person trying to read what's going on. Monographs are much easier to read. Anyway, demo 2, this function doesn't work, of course, because we have got unbalanced brackets, so that doesn't work at the moment. Here's an alternative way of doing it, which is a cheat. I'm using one of my own, part of my model here, this is an operator. I've put braces around here, so this is now an embedded function, and this operator just extracts the data from that. So that's the cheat, the model doing what APL should be doing. Straight away into 3 dimensions, here's another function, here's another array. We have a 2-row matrix there, we have a 2-row matrix there, with brackets around it. So it's obviously going to be a 3D array. And there it is. Somewhere or another, we need to get this stuff into a function in the first place. I would suggest some new calling sequence for either format or quadfmt, which does something like this. We give it a two-row matrix, and it produces a 2-row expression instead. Can't currently execute that, so I've written another function called expression. Whoops, not sure what happened there. Oh no, that's it. Which produces the same thing with a diamond in between, which we can execute with an evaluation function, and that again returns our matrix. M was this 3D array up here, so FMT that, and we get the a 4-line expression, which will do the same thing. Can't execute that at the moment, so using diamonds instead. Can we evaluate that? Well, not at the moment because my font size is too big. So we join the rows together again, and we get our 3D array back from there. I mentioned earlier I wrote an editor using QuadSM and display. We don't really need that. If we can format a thing into a multi-line expression, we can edit the expression and then evaluate it again. So looking at M again, which is our 3D array, I'm going to edit it, put it into N. Here's our multi-line expression. If I break these apart a little bit to make it more easy to see what's going on, and let's just add another plane. There we go, that will do. And in is now got 3 planes to it. That's about it really, unless there are questions.
I was talking through the same kind of problem back when we were trying to do the workspace interchange standard in the dark ages. And one of the problems we ran into was treatment of what we would call control characters or non-printable characters outside the standard ASCII and APL set. So I have a character vector containing, say, a line feed or carriage return, tab, etc. How do you propose to handle those?
I've actually done it in this model. I'm using I can't even remember what it is. I think I'm using a hash symbol as the escape character, followed by 4 hex digits. Quite similar to the JSON approach. So any character you can type as the hash symbol followed by 4 hex digits.
Yeah, I noticed in your notation you're using nested square brackets there to represent arrays of higher rank. So is there any room in that system to represent nested arrays?
Right, okay. I mentioned there's a difference between notation and code. Okay. I have no instances in what I've shown you of nested arrays. Okay, right. What I attempted to point out at the beginning was that this session I will include in a document and annotate it and post it somewhere where everyone can see it. And it includes nested arrays, includes dictionaries, includes unit dimensions and empties, all of which are anomalies in here.
Okay.
Excellent. We'll look forward to that. Thank you for joining us, Phil.
Yeah, we miss you.